Hi, welcome back for another 4 Caillou challenge called Sum Strings as Numbers. Given the string representations of two integers, return the string representation of the sum of those integers. For example, if you have a string, these should, remember, we know single quotes represent characters, so they made a mistake there. They should be double quotes. The string 1 and the string 2 should return the string 3 because 1 plus 2 is 3. A string representation of an integer will contain no characters besides the 10 numerals 0 to 9. I have removed the use of big integer and big decimal in Java. So the catch here is that converting to an int won't work. And I tried that just for fun because it's easy to do. And sure enough, yeah, when you run the full attempt, the values in the strings are just humongous. They won't even fit into an integer if you try to use int parse. So put on your thinking cap for a minute, see if you can come up with another clever way of handling this. That's what I had to do. And then I will get into my solution. So go ahead and resume the video when you are ready. Now, my strategy was, basically, I'm going to keep the two inputs as strings, and I'm going to line them up so they're the same length. If one is a shorter value than the other, so in this example, we see they're both 3 digits, but imagine one was 10 and one was 4. Then I'm going to pad the other one with leading zeros to make the two inputs the same length. The idea then is that I create a for loop. I start at the end, and I sort of grab each character from each input at a time and add those two values and convert it back to a string and sort of build up some kind of result this way. I'll use a string here, but you could use string builder as well. We've talked about that before. So yeah, like I said, imagine something like this. For each, actually, let's do the other parts first. So we could say int length 1 equals a dot length, length 2 equals b dot length. You could just always refer to b dot length and a dot length if you don't want to create placeholder variables here. And we could say diff, I'll call it the difference between the two. It's going to be math absolute value of a minus b. That way it doesn't matter if a is bigger or smaller than b. We just care about that magnitude of the difference between them. So good. Now we have the lengths. We know the difference between them. This difference is going to sort of show us how many leading zeros we need to add in. So I'm going to also note the max length. That will be useful for our loop. So I could say int max length. You could even keep this all on the same line if you wanted to. That would be math max length 1, length 2. Just takes two parameters and it uses the larger of the two values. If you use max, you may have guessed there's a min as well if you want a minimum. Good. So now we know the maximum of the two. And then one more variable I'll introduce here. I'm going to use a carry boolean, and I'm going to start it to false because we don't start our addition. Imagine just like how you used to add on paper when you were a kid, right? You start in the ones place, you add them. If there's a carry, you move it over to the tens place on top. You add those 10 values and add the carry if necessary. We're going to do the same kind of thing right here. So I could say for int I equals 0. Actually, no, we're going to go from the back, right? Because I want to start with the ones place. So I'll say for I equals max length minus 1. Remember, collections are 0-based indexing, so I have to have that minus 1 so I don't run past the end of the bounds. And then we could say while I is greater than or equal to 0, and instead of incrementing I, we're going to decrement it. We're going to keep moving towards that most significant digit. And then in here is where we sort of work with the additions. But before I do that, let's make sure we get our padding done, right? We got to make sure these two values line up appropriately and that we have values to extract. You can imagine if one was 10 and one was 5, once you get to position 6, you know, one of the inputs isn't even providing a character anymore, and so that could cause trouble. That's why I went to the trouble of padding these. So I'll say if length 1 is less than length 2, that means that length 1 needs to be padded, right? So we could say that represents A. We're going to update A to be A pad left. And you should probably seen pad left from me already. You give it the total width and then the character you want to pad with. So our total width would be max length, and the padding character would be a 0. We want leading zeros. And then we'll say else if length 2 is less than length 1, it's going to be the same thing, but for B pad left, max length. It means that's the one that needed to be padded. And then if they're equal length, we don't have to do anything. They're fine, right? They're going to line up. So now we can go into the for loop and handle that. So let's create a little local variable here that will handle adding whatever digits we're looking at a given time. So remember, this is going to start in the with the ones place. And so how I can access those is I could say AI. Remember, A is going to be the max value to start, -1. It's going to start at the end of A. So if this was A 579, it's going to start with the 9. Next time through the loop, it's going to do the 7. Next time through the loop, it's going to do the 5. So let me see if I can blow this up for you. Okay. So yeah, AI. But remember, this is going to give the character, right? And I'm doing some integer stuff here. I'm going to be adding. So what I'm going to do is to convert this character to an integer, I'm going to subtract 0 from it. And I probably don't need these parentheses, but I'm going to put them in just to teach you that if you're not sure, you can add the parentheses and it doesn't hurt. So this is going to get some characters from 0 to 9. Remember that challenge guaranteed that. And when it minuses the value for 0, you're sort of left with the difference. Remember from the ASCII table, if we look at the numbers, where are they? 1. Here's 0 through 9. So 0 is actually 48, right? Imagine you had the number 4. It's 52. So if you take 52 minus 48, you get 4, right? See how I'm doing that? I'm just getting the integer value, sort of extracting the integer value from the character. That's why we're doing that. And so we want to add the other character, the B1, so it's the same thing, right? We're just going to get whatever its numerical value is. And then finally, don't forget, you could have a carry. Remember, carry will be false the first time. But if you have a carry, add 1. Otherwise, you don't need to add anything if there's no carry. So good. That will give us the new character that needs to be added. So how do we put that into our string result? Well, we're going to update it. We're going to say result insert. String has an insert method. If you don't recall that, feel free to consult the documentation where you give it the position you want to insert. I'm going to always insert at the beginning of the string, right? So when I do the ones place and then I do the tens place, I don't want to add the tens place to the end, right? That would print our answer backwards. So I'm always going to sort of prepend. You could think of it as prepending the new value that I'm working with. So sum, but remember sum here, imagine it was 7 plus 7, that's going to be 14. It could be too big, right? So we just want the ones place of the sum, and then if we have any excess, we'll set the carry flag. So the way I could do this is I could say sum modulo 10 to get the ones place value of sum there. Remember, sum modulo 10 is just sum divided by 10, and it takes the remainder, and that's why it works out to be the ones place. And since this is an integral value, I'm actually going to have to convert it to a string if I want to insert it into a string, right? So I'll say, take that value and convert it to a string. Good. So yeah, we're going to get the result of that single addition. And then we have the matter of setting the carry flag. Well, when do you carry when you add up? It's whenever sum is greater than or equal to 10, right? It's whenever it hits 2 digits, you have to do some carrying. So then the next time through, if necessary, carry flag will be set. We'll come through the for loop again. This time carry may be 1, it may not, but if it is, we'll get that extra 1 added to our new addition here for whatever position we are in the inputs. And then as you can imagine, you're going to go through that and it's going to add up all the digits. There's one concern where imagine you get to the very end, you're at the most significant digit, and you add them up and it goes over 10. So it's possible carry could still be set. Remember, if carry, we've got to handle that. We can't just ignore that carry at the beginning, right? So we're going to say result equals result insert 0. We're going to prepend the value 1 because there's nothing else to add to. It's just the carry, so that's why it's a 1. And then finally, once you do that, you're going to have your sum. I'll show you a return result. It's not quite right, and maybe you can guess why, but we'll take a look. Well, they're going to make me, maybe I'll just do it now. We want to avoid any sort of leading zeros. Let me see if I can shrink this back. You'll see this won't be quite right. Well, that definitely won't be right. That'll be a compiler error. So let's do this and just kind of see where we're at. It's quite possible I made a typing mistake too. Okay, error operator on line 7 could not be applied to operands of type A and B. Sure, yeah, I'm just subtracting strings there. That doesn't really make sense. How about if we do their lengths? That's what I meant to get the difference of. Oh, lengths. I'm typing what I'm thinking and saying. So good, we hit green there, and I'll hit the attempt. So not quite right. Look at this and what happened here. We were mostly right. Technically we were right, but no leading zeros there. So we got stuck with a leading zero. So all I'm going to do is, and if you want, you can even pause and think of how you would clean this up. I'm going to use some link to do that. So let me go ahead and add using system link. And then instead of result, how about if we do a skip while? Skip while. Remember, there's a skip where you can just tell it how many to go, but I don't know how many leading zeros there are. So I'll just say skip while, skip while. Remember, result is a string, so each element is a character. I like to use ch for my parameter name for characters. And I will say skip while that character equals 0. Because it's going to skip while is going to start at the beginning, and it'll keep skipping any zeros. And then once it hits a non-zero value, it should be fine. But remember, skip while, like most of these link methods, are going to return an IEnumerable of the type they were invoked on. So let's form this back into a string. I commonly use this idiom string join, and I don't want any spaces between the values. Return string join that. So it's going to take that IEnumerable and put it back into a string with no spaces between the values, right? We don't want spaces between 8670. So let me see how this works for us. And bam, look at that. We nailed it. So yeah, maybe if you tried parsing to integers too, you would have found out that some of these values here are just humongous, and it didn't work. But we'll go over this one more time real quick. Oop, there we go. Well, I've got to get the, nope, that's not it. I got to get a little better at the zooming. Without throwing everything off. So yeah, I just grabbed our solution there. And yeah, so we determined, we adjusted in case A and B weren't the same length. We padded with zeros to make them match. That way we could line up every character just like we did addition in grade school, and doing character by, or position by position, I should say, ones place, tens place, hundreds place, etc. Making sure we include carries where needed. If we had an extra carryover from the very last edition, make sure you include that too. And then finally this bit at the end to strip leading zeros, because that is not the way the output should be formatted. So that said, I think I'll fire mine off like this. We can check out what other people did. And oh, I didn't even try using big integer because I thought they said you can't do that. Okay. All right, maybe I should have not just trusted them. Either way, it was cool to do it the way we did too. This is cool. They're using a stack here. You might want to look into that. It's a very good data structure. More people cheating with big integer. Oh, you cheaters. Int parse. How'd you get away with int parse? I don't know about that. I thought when I did it, they had huge input values. So yeah, a lot of cheaters. Well, I'm happy I listened to the rules. It was another way to look at it. Kind of clever. Anyways, that's it. Feel free to hit me up with your questions, comments, feedback. I appreciate those likes and subs. Otherwise, we will keep rolling. I'll see you in another one. Thank you.